Now let us just recap what we did in problem 2.6 and which of these tips and tricks we may use in later problem solving. So one of the things that we used was the formula for conditional expectation. So that is one thing that is good to remember in the future, and especially how we calculate the expected value of x restricted to a set in the continuous case, because this is the first time we have done that. Another thing that we did was that we went through how to use the partial integration formula. So integration by parts plays a huge role in this course in the sense that it's a really good idea if you know how to do it. So that also is a very good idea to write into your formula collection. Another thing that is good to remember in general is if we have a density of a distribution, then we can use that to find the distribution function. And the way we do that is we integrate the density from minus infinity all the way up to x if we want to find the distribution function's value in x. Now during the course of doing this, it's very important to remember where the density function is defined. If it's, for example, defined only for x greater than 0, then the distribution function is equal to 0 elsewhere, and we only are interested in the distribution function for x greater than 0. And also, if the density is only defined for some value greater than for greater than some value, then it needs to go into the integral's boundaries as well. So we have to remember that part. Also, one last thing is that if I want to find the probability that x lies inside some interval, then that is the same as taking the distribution function in the greatest interval endpoint minus the distribution function in the lowest interval endpoint. The last thing that we may bring on with us from this exercise is, in general, if I want to find the mean, maybe I should write this somewhere else. Let's see. So, I don't know where to write. Just write this here. That in general, if I want to find the mean of some expression of x, where x is continuously distributed, so we assume that x is a continuous random variable, then the mean of an expression of x is given by the integral of g of x multiplied by the density of x. If g is integrable with respect to the distribution, in the sense that if this absolute value of g multiplied by f of x dx integrates to something that's smaller than infinity. So remember this for future exercises, especially, for example, if the density only exists for x between a and b, for example, then these boundaries should be a and b. And then it's quite clear that then this expression is less than infinity in those cases. So remember these things for future exercises. It's always a good idea after you finish an exercise to go through the way you solved it, try to write some notes for some different solution techniques, and try to remind yourself what you learned from the exercise, because this way, the more exercises you do, the more knowledge you accumulate. So thank you for this week, and I'll see you guys in the chapter 2 solutions for next week, in the next week.